This is Chapter 11, Part 2. We are continuing Example 2. We've been asked to change the dosage rate into the flow rate in milliliters per hour. If you look at Part A, we had the dosage rate at 1 gram for every 30 minutes. Okay. Now, we are supposed to change this into milliliters per hour. Let's go ahead and change it into hours. 60 minutes in 1 hour. Okay, so we end up with 2 grams per hour, which is what we had on the previous page. Now we need to change this into milliliters per hour. Okay, into milliliters. So we look at the label and we see that each 50 milliliters contains 1 gram. Okay, so that's your relationship. We can get rid of the 1 gram, and then we put the 50 milliliters in the top. The grams cancel. We multiply 2 and 50 to get 100 milliliters per hour. Okay, Part C. Change the flow rate from milliliters per hour, which we got right here, to drops per minute if the drop factor is 10 drops per milliliter. Okay, so the flow rate we said was 100 milliliters per 1 hour. We have the drop factor of 10 drops per milliliter. I want to get rid of milliliters, so I'm going to put 1 milliliter in the bottom and then 10 drops in the top. Okay, so milliliters cancel, and right now I have 1,000 drops in 1 hour. We are asked to find drops per minute, so let's convert hours into minutes, which will give me, I have 1 hour up here and then 60 minutes in the bottom. The hours cancel out, and we need to do 1,000 divided by 60 to get approximately 16.7 drops per minute. And we have drops per minute. Okay, so that should be our answer. All right, let's look at example 3. The medication order reads that we're supposed to give, 1 gram over 30 minutes. Read the label. The directions indicate that the vial should be reconstituted with 10 milliliters of sterile water and then added to 50 milliliters. Calculate the flow rate, okay, in milliliters per hour. Okay. So the first thing we have to do, if we're going to do milliliters per hour, this is going to be the volume of what we're giving over time. And we're going to add 10 milliliters to 50 milliliters. So our total volume is 60 milliliters. Okay, so that's actually how much we're going to be given. So what we have here is we have 60 milliliters given over 30 minutes. Okay, now we are asked to give it in milliliters per hour, so we need to get rid of these minutes. There are 60 minutes in 1 hour. The minutes cancel. You can reduce this. 30 goes into 60 twice. So we have 2 times 60, which is 120 milliliters per hour. Okay, now part B, find drops per minute if the drop factor is 10 drops per milliliter. Okay, I'm going to come back to right here. We have 60 milliliters for every 30 minutes. Okay, the drop factor, we want drops in the top and we want minutes. So 10 drops per milliliter, I want the milliliters to cancel out, so I'm going to put 1 ml down here, and then 10 drops here. The milliliters cancel out, and again 30 goes into 60 twice. So we end up with 2 times 10, which is 20 drops per minute. And that should be our answer. Okay, example 4. The medication order reads heparin 1,250 units per hour. The IV solution has 10,000 units of heparin in 1,000 milliliters. Calculate the infusion rate in milliliters per hour. Okay, what we know right now is we are given this. So I'm going to start off with 1,250 units per hour. Okay. We want milliliters per hour. We have hours, so that's good. We just need to turn units into milliliters. The relationship we need right here is 10,000 units for 1,000 milliliters. I'm trying to get rid of units, so I'm going to put 10,000 units in the bottom, and then put the 1,000 milliliters in the top. Units are going to cancel. We have some pretty big numbers here, but remember you can cancel out zeros. Basically, if I divide this by 1,000 and divide this by 1,000, I'm going to lose 3 zeros on each of them and end up with 1 over 10. Okay, so now if I multiply straight across, I have, or if you have multiply straight across, I have 1,250 over 10 milliliters per hour. And of course, that reduces to 125 milliliters per hour.